Welcome at 30-1 to a quick review of exponents and the exponent laws, okay? So to start off here, this whole thing is called a power, all right? These are just some definitions that you need to know, and we've done this since grade 9, 10, and 11, so this is just a review of the last few years. Now the little n is called the exponent, so my laws are about the exponents, okay? And the next one here, the A is my base. All right? So those are three definitions you must know. When we say power, it's referring to everything. The exponent only refers to this little n guy, the little guy on top, how many times we multiply the base together. And the base is the thing that we're multiplying together. Okay? All right, so here we go. We're going to now go right back into these laws here just to review. So product law is we have to add them, okay? So that is x to the m plus n. The power of a power is x to the m multiplied by n. This one here, power of a quotient, we have x to the m all over y to the m. Both of these must put to the power. The integral form is 1 over x to the m. All right? Now rational exponents can be expressed two ways. We could express it as, this could be m x to the m, or and all of that to the m. There's two ways we could do that. Now the quotient law is we subtract x to the m, subtract n, and the power of a product is x to the m, y to the m. We have to use it to both. Okay, it's kind of like distributive law. All right, so let's continue here. Write each expression without brackets and with positive exponents. So without brackets and with positive exponents. So this -6 only refers to the y. So we're going to get 1 over 2 y to the 6. We use the integral law. Okay? Next one here is, this is to the -3 and this is to the -3. So this guy wants to go on top, because that's 1 over y. And this guy wants to go on the bottom, because it's 1 over x. So we have 5y squared all over x cubed. All right? Now let's take a look at this one here. This is the same, good. And then we have this. So we have 4x cubed y. Now these must go on the bottom. This must go on the bottom. So it's multiplied by 2. This is still on the top. But this here goes on the bottom, and this stays on top, y squared. And we have all over x to the 4. Now, this x cancels off with that, so we're left with just x on the bottom. And these multiply together to give me 8. And we have y to the 3. There's my answer. Okay, we got rid of my brackets and multiplied everything together. This next one here, I have a lot of things that are negative. I'm going to put all my negatives on the bottom and my positives on top. But notice this negative here, that's not a negative exponent, so we can't apply the integral rule. Every once in a while students make that mistake, they get carried away with the negatives. All right, so I have 24m to the 5, it's 4m to the 4. This p is negative, so I'm going to put it down. So I have p squared. I'll first put on my positives, q to the 4. And I have now my negatives, p to the 3. And this one must go on top because this is negative, q squared. So that leaves me with, both of these can be divided by 4, 6, m. These cancel off. I'm left with just 1m. And then we have q's to the 6, all over p to the power of 5. There we go, that one's done. Let's take a look at the next one here. We have power to a power, but we also have power of a product. So remember, it goes into everything. And then we have other exponents, so power to a power. So I have 3 to the 3, and we're going to have x to the 2 multiplied by 3, y to the 3 multiplied by 3, which gives me 27, x to the 6, y to the 9. And that's done. Last one here. Okay, we have just this here to the -1 over 2, and this is b. So I get, well, 12 divided by 3 is 4, and I'm going to end up all over b to the 1 over 2, and then we have b. Well, this is to the 1. I add these together. What is 1 plus 1 over 2? That gives me 2 over 2 plus 1 over 2, which gives me 3 over 2. Remember adding fractions? We still must do that. So that's 4 all over b to the 3 over 2. Okay? Or we could even put that in this form here. So that is 4, we could say all over we square root of b to the 3. We could also say that. So either one of these would be good. Okay? Let's take a look here at example 2. It says, simplify the following, write the answers with positive exponents. So same idea, we must write with positive exponents. So first of all, I'm going to multiply this in here. So we do what's in brackets, and we're going to multiply that in. So I'm going to end up getting 4 to the negative 3, x to the negative 3, and y to the positive 6. Negative 2 times negative 3 is positive 6. So we end up getting y to the power of 6 all over 4 to the negative 3 is going to be 4 to the 3, which is 64, and we have x to the 3, so that's y to the power of 6 all over 64, x to the 3. And this is my solution. Let's take a look at this next one. Okay? Now we're going to multiply this negative 2 into everything in here. Okay, so I end up getting 3 to the negative 2, x to the negative 6, right? Now negative 2 into all of those. So I end up getting 4 to the, what is this? Negative 2, y to the negative, y to the positive 4, because that's a negative and a negative. Okay? So we end up going here, and I'm going to end up getting, flip everything that has negative exponents. We have 4 squared all over 3 squared, x to the 6, y to the 4, which gives me 16 all over 9, x to the 6, y to the 4. Now there is another way of doing this is, since this is a negative, I could have flipped both of these in there, and I could have just said 3x, and just flipped it first, and I've had 4y to the negative 2 all over 3x to the 3 all squared, and then squared everything, and it would have eventually given me the same answer. So there's more than one ways of tackling these problems. All right, let's take a look at the next one. It says, without the use of a calculator, determine the following, and then verify with a calculator. All right, well, 2 to the negative 3 is 1 over 2 to the 3, which is the same as 1 over 8. Okay, and that's it. All right, well, that's the same thing as 1 over 4 is 2/5, so that's 0.125, I believe. Okay, that's what that equals. Now, let's take a look at the next one. Put this down. So we have 81 to the power of 3 over 4. So we have 81. We want the 4th root and then cube it. So what's the 4th root of 81? That's the same as, we could break this down, that's 81 is 9 times 9. And these are 3's each. So there's 4 3's there. So that's going to be 3 and cubed, which just gives me 27. That one's done. All right? Now let's try the next one, which is 25 to the power of 0. Well, if we remember our laws, anything to the power of 0 is what? If I go, let's go 2 to the 3 is equal to 8. 2 to the 2 is equal to 4. 2 to the 1 is equal to 2. Every time we're dividing by 2, divide by 2. So next would be 2 to the 0, we divide by 2, is equal to 1. Okay? Because we're just dividing by the same thing over and over. So anything to the power of 0 is 1. All right? Let's take a look at the next one here. We have 16 to the negative 1 over 2. Well, that's a negative. So that means we have 1 over square root of 16. Or 16, 1 over 16 to the 1 over 2. This is the square root. So this gives me 1 over 4, which is the same as 0.25. Or 1 over 4. We could always leave it as a fraction. Or I like fractions better. I think they're better answers. They're more exact. Okay? Here we go. Class example number 4 is the change of base. Okay? So it says convert each of the following to the base indicated. Well, we want to base 3, so this must be base 3. 9 is the same as 3 squared. Okay? And we still have 2 to the x, because 3 squared is the exact same as 9. Now we could multiply these in, so that's 3 to the 4x. Okay? Let's take a look at this next one. Base of 5. Well, 5 to the power of 3 is equal to 125, right? So we get 5 to the 3 all to the 2 subtract x. So this 2 subtract x must be multiplied into the 3. So we get 5 to the 6 subtract 3x. All right? Let's take a look at the next one. Base of 2. We have two things here. So we could combine those, which is so nice. So 8 is the same as 2 to the 3 is equal to 8, and 2 to the 4 is equal to 16. Right? So there you have 2 to the 3 multiplied by 2 to the 4 to the x. So that gives me 2 to the 3 multiplied by 2 to the 4x. Now what does this mean? Multiplication is, well, product law. So we end up getting 2 to the 4x plus 3, because we're multiplying these. That means we add the exponents. Common bases, we get to add the exponents. Before, these bases were common, we couldn't really simplify them. So we make them common, now we can add the bases. All right, next one, we want to change this to base 2. So we have 512. Okay, so 512 is, I think, 2 to the power of 8. If I, right, just wait. 512 is going to be 2 to the power of 9, I think. So 2 to the 4 is equal to 16, and 16 times 16 is 256. So it's 2 to the power of 9, sorry. So this is equal to 2 to the power of 9. All right? So we have 2 to the power of 9. So it's 1 over 2 to the power of 9 multiplied by 3x, which will give me 1 over 2 to the 27x. And there we go. That is my solution. Or I could say 2 to the negative 27x. Okay? One of these would work. Let's take a look at the next one. We want to the base 2 over 3. Well, 2 to the power of 4 is equal to 16. And 3 to the power of 4 is equal to 16. Well, look at that. 2 over 3. That could be 2 over 3. So let's try and do this here. We're going to end up getting 2 over 3 all to the power of 4, then we bracket x plus 5. So we end up getting 2 over 3 multiplied by 4x plus 20. And that is my solution. Okay? It's just right there. All right. Okay, so now let's go to example number 5. It says solve for x. All right? So here, we want to solve for x. Now, the best way for doing this is we're going to put them into the same base if possible. So we did the change of bases, but it's hard to do that, isn't it? We want these in the same base, or to the same exponent. So why don't I make this to 1, so I get x by itself. We want to isolate for x. We can't go in the same base, they're on the same basis, so we're going to make them in the same exponents. So here we go. I'm going to get x is equal to, and I have negative 4 over 3. I'm going to multiply this by negative 3 over 4. So we have 81 to the negative 3 over 4. So I end up getting x is equal to 81 to the negative 3 over 4. Oh, what does that give me? 1 over 81 to the 3 over 4. Okay? So that's the same thing as 1 over, and we want the fourth root of 81, which is 3 cubed, which is equal to 1 over 27 is my answer. All right? Let's take a look at the next one here. All right, so we want this to be in that, but now we can't make the bases the same. So what we're going to do is we're going to get them to have the same exponents. Therefore, we can solve it like we solved everything else from before. So we have 3x, subtract 5, and we have 3 over 2. I'm going to multiply the exponent by the reciprocal, 2 over 3. What I do to one side, I must do to the other, 27 to the 2 over 3. Now I'm going to be left with 3x, subtract 5, is equal to 27 to the 2 over 3. All right, let's solve this. Well, the cubed root of 27 is 3. And then we want the square. Okay, so we continue this. I'm going to end up getting 9, and I'm going to plus 5, plus 5, plus 5, and we get 3x. Now we end up here with 14, x divided by 3, divided by 3. So I get 14 over 3 is equal to x. So once we get a variable on the bottom, okay, so if we have a variable right here in the base, and we're trying to solve for it, and we have different exponents, well, isolate your variable and make it to the power of 1. So we have x to the power of 1. We want to isolate your variable to the power of 1. And in order to do that, normally if your variable has an exponent, we must multiply all the exponents by the reciprocal of that exponent and then solve for x. Because if we multiply by the reciprocal, that ends up balancing everything out and everything's nice. Okay? Because then it makes it 1. So there we go. Hopefully you understood this. Good luck as I see you tomorrow. If you have any questions, don't hesitate to ask.